Good afternoon or good morning, everyone. I know Dawn isn't able to attend today. We'll wait one more minute for some stragglers to join, and I'll kick off the recording and we'll get started. All right, let me kick off the recording. Welcome everyone to the April 28th Kubernetes Signal meeting. Just a reminder that the meetings are recorded for posterity and will be uploaded to the playlists on YouTube shortly thereafterwards. We have a number of items on today's agenda. First item was from Balaji. If you want to see if we've had time from folks in the community to review your proposal.
Yeah, okay, so before that I want to call it out, looks like I had a wrong link in the agenda, so I'm not sure if everybody looked at it. So I had a link for the disable logs handler, the other PR that I was driving in the agenda instead of adding the enhancement PR link.
Yeah, so I know in last week's Sigma meeting we talked about this. For myself personally, I've been trying to prepare for the Red Hat Summit digital event this week, so I've had less time to review enhancements. I don't know if anyone else has had an opportunity that wanted to raise some concerns or both pros and cons, I guess. Okay, so maybe Balaji, I apologize if maybe Donna had a chance to review it, and unfortunately I know she said an urgent issue today. But thank you for the reminder, and then I know in my case, once Red Hat Summit is done this week, I will have more cycles to review your proposal.
Yeah, so do you want me to add this as to the next week, or do you want me to wait?
Yeah, I think it's great to heartbeat on it, and so I have no concerns on just pushing this to next week, if that's okay.
Okay, cool, thank you.
Looks like the next item on the agenda was around discussing the concept of a container notifier. Is the proposed speaker available to talk through that?
Yeah, this is Shane here. So also Shan Chen is here as well. We actually sent out an email to the mailing list. Not sure if anyone paid attention to that about this. We first started discussing about this in the data protection work group because we want to take application snapshot. We want to have a way to quiesce the application before taking a snapshot and unquiesce after that. So for that, we need to send a command to the pod to trigger some command to do the quiesce. And then Tim Hawken, he was reviewing that. He mentioned that there are many other use cases. He actually opened an issue to request this feature a long time ago to have a way to send a signal to the pod to trigger some command. Oh, should I share this doc? Or it's okay? Or you want to share?
I think it's great if you're able to share.
Okay. Do I have? I think I need to be a co-host in order to share anything. Or otherwise, you can share because I think they disallow anyone who is not a co-host to share anything now. Okay,
Yeah,
next.
so I just gave you co-host. Hopefully you should have a share button.
Okay. All right, so here we listed the use cases, right? So there was be able to run commanding a pod to quiet an application before taking a snapshot, unquiet afterwards to make sure.
Is it using snapshot, like CRIU, like checkpoint restore, or?
So this is for, so for the snapshot, this is like the, we're talking about the application snapshot here. So it could be, like you have like MongoDB or something, you run some command to quiet the database.
Okay.
Yeah. And then there are a few other use cases like send a signal, say you want to reload the configurations, start an upgrade, or you want to start some database migration. So those are other use cases you want to be able to send a signal to the pod. So because of that, there are multiple use cases. So we want to have a common way to do this type of thing. And also we want to make this secure. So have Kubelet execute those commands will be more secure. So that's why we are having this proposal here. There are two parts. The first is to have a inline pod definition for a container notifier, and then which defines what type of command you want to run inside the container. And the second part is to have a notification API object to request this type of container notifier. So the inline pod definition would be something like this. So inside a container, you have this notifiers. So because there could be multiple of them, that's why this is an array. And then the definition of this container notifier, you have a unique name. And then the handler basically specifies how you run the command. That's an exact action. And then it's timeout. So this is the definition inside the container itself. And then we also need to have this notification API object. So this will be a API object because we need to be able to tell Kubelet when to run this. So it's an external controller will be creating this API object. And then in the spec, this will have the container notifier name. And then also it will specify how to select a pod to run this command. And then the status, basically after this command is run, Kubelet needs to change the status so the external controller knows, okay, this is complete or not. So that's at a high level, that's what this one is. So we want to know if, I don't know if anyone has got a chance to look at this. We haven't really written a full-blown CAC yet. We'd like to collect some feedback.
Xing?
Yeah.
What specifically would be executed inside the kubelet and what would be executed inside the container itself?
Oh, so it's basically so this will be similar to there's this pre-stop and post-start.
Right.
Type of things. It's similar to that, but this is because for that you actually know exactly when to run those, right? For this other type of notifications, the Kubelet does not know when to run them, so that's why we need to have a way for an external controller to tell it what to run. So, for example, if you want to, so I just want to use the example of taking a snapshot, application snapshot, right? So if you want to snapshot your MySQL. Then you need to run commands like mock tables, right? So you need to run that command inside the container. So that would be type of command you run.
Right. What would Kubelet actually be executing? Would it be sending a signal to a container process? Would it? What type of
so it's going to be run.
Are you expecting? That's it.
So this is going to be same as this other command. So I think probably this here explains it well. Just this is the same as your post-start pre
Exec sync.
yeah. So you run this inside the container. I'm sorry.
So CRI exec sync API call will be called, right? And then
That is if you're running from outside, right? But right now we're talking about that's will be the same similar thing. If you're running kubectl exec, but that's you're running from outside, right? But this is just you will be able to run this command inside the container directly.
No, I understand that, but in the case of the start and stop, there's a specific time there's a specific time period in which those lifecycle hooks execute within the container. Obviously on start and stop. With this, however, it is triggered based on a kubelet
external. So kubelet will be watching.
There's a new notification event, right?
Correct.
So how is kubelet? How are you planning on having kubelet communicate with the container itself?
So kubelet.
How does kubelet tell the container, "Hey, I just got a notification that quiesce or event"?
Yeah, so kubelet will be running. So because we will have those command defined, right? So kubelet will be running those. Command. So that's the same as how you run. It's only the timing you have to know from outside. You need to be triggered from outside to know when to run this. But the way to run the command should be the same as all those other commands.
Okay.
Yeah.
Okay.
Right. So so we have to be able to communicate between this external controller and kubelet. So right now the proposal is to say, okay, an external controller will create this notification object to request that I want to run this signal. And then kubelet will be watching this notification object. When it sees this, it knows, okay, now I need to find this and then run it. And then there is also this status field that tells the external controller whether this is being triggered, it's still being running, or it's completed. So that's the way for the two to communicate with each other.
So I have a couple questions, if that's okay. Is there an expectation that the kubelet delivers this notification no more than once?
So those are the things that we need to discuss. But we would want to have some retries if it does not. If the first try did not succeed, then there should be some retries. But then, of course, we don't want this one to be running forever. There should be because this is like time sensitive, right? So we also don't want the application to be frozen forever. So there are some. So we do right now. We do have this specified here, which is inside this container notifier, which there's a timeout thing. And then the retries will be, it can be handled by let's say the external controller can be sending out this request and waiting and to see whether there is any change, whether the status is changed or not. So I think those type of details we still need to iron out because we like to get some initial feedback first. But we can write more details on that, like how the coordination and then how long we should wait, and how many retries is allowed, I think, type of thing.
Yeah. So basically, I just trying to think through first feedback that comes to mind, and I apologize I hadn't read this prior, but you're getting kind of like top of mind feedback. So understanding how many times you'd expect the kubelet to deliver a signal, and what it should do when it is unable to deliver that signal is probably the first thought that comes to mind. The second thought that comes to mind is like today the kubelet basically updates two objects, well, really three objects: a node the node lease and the pod status is kind of what I typically think of as like the primary.
I'm sorry, what's the second one?
The node lease, the node
Oh,
status,
lease. Oh, okay.
and the pod status, right? And so
Okay.
that's kind of like the heart, the feedback loop from kubelet to control plane that I think about. And this
Okay.
introduce a new
Okay.
feedback loop on a new object. And so I'm wondering like what the right cadence would be expected on that object and if it would differ from pod status. So maybe talking through expectations on that would be helpful, because one of the things that would concern me is like if we try to increase pod density, what is the factor of that and the kubelet's ability to write back notification status, just as an example. So that's one thought. The other thought is what would be garbage collecting this notification resource? Is it kind of ephemeral like events? Or what were thoughts there would be good to think through. Understanding the relationship of this resource with the node authorizer is also helpful to understand. So today, like, one of the things that we are careful about is how many resources the kubelet chooses to list and watch. And so today we list watch pods, but only bound to that node. And then things like secrets and config maps, we kind of have to handle via a caching mechanism. And so understanding how you would expect this notifier to be kind of watched by the kubelet at scale would be useful.
Okay.
And I'm trying to think for others on the call might have other thoughts that come to mind, but those are the first few.
Okay, so there is somebody, the Kevin Fox, he has some comments, he added some comments here about this pod security policy. I think Tim replied that, I think basically, you can read this. Basically, Kevin was saying, oh, maybe we should have something like this. Tim was saying that does not look like we have done something at this granularity, but what does anybody else think? So I think there's some comments here.
Pod security policy is kind of a different layer than I'm talking about for the node authorizer. So if you wanted to look up the node authorizer afterwards, it's basically an admission plugin that restricts the set of resources that a kubelet can see beyond traditional RBAC. So for example, the way that the kubelet is only able to see secrets that are associated with a pod that are bound to that node is done via node authorizer. And so I'm wondering if we would need to treat notifications similar. The last thought I would have is just if you wanted to explore this idea outside of the kubelet first, is it possible to do everything you need as a privileged daemon set?
Privileged daemon set. So what we have done previously, we actually have another cap that was already merged like more than a year ago, which we have everything outside. Basically, it's so like the hook itself is a CRD, and then we have a controller which is also external. We will use this, the pod exec sub resource to do this type of thing. So that was something that we have already done. But then the CAP was merged, and then we were doing the implementation, and then the API reviewers, including Tim, I think it was somebody else, Daniel. So they were saying that this should be better be handled inside the container itself. So that's why we are doing a completely different design.
Okay, well, appreciate your patience in working that through the various parts of Kubernetes. I guess what I'm curious is how far you got with that approach. Like, were you able to prototype it even if your API couldn't be?
Yeah, we actually have an implementation of that. It was during the code review. We were asked to think about this approach. So I think that's why Tim was actually saying that I want us to, come to the SIG node and see what you guys are thinking, and then, get some feedback. before we are getting too deep into the design. So if
I guess were you able?
Yeah, so
you showed a change to the pod spec, which I could see as being broader in scope. And so what I'm wondering is if when you explored a CRD only mechanism, did you explore that without requiring a change to the pod spec? And then how far were you able to go in that exercise to learn what may or may not work well with the approach?
So that approach would work. It's flexible. I think the concern is from the API reviewer is the security aspect. I think that's the mainly concern. So I should I find that our original cap. So we actually went through several different designs. So this is another one. So this cap, let me find it. I can go to this. This is the original cap. We actually even opened a repo just to implement this one, and then implementing the API and the controller, and then we got this comments to do this completely differently. So this one, look, let me actually go to this proposal. Let's see. Yeah, so this is a completely a CRD approach. Right, so here in the CRD, you select pod, and then you have the action. Action defines how you want to run the command inside a container. So that would work. Yeah.
And at the end of the day, when you explored your implementation, you had a daemon set running on each node that was privileged that then did that exec action in the container, or I'm curious how far you got code-wise.
So code-wise, we basically have the APIs, and then we have the controller. That is actually in this. We have several PRs there. Then it just should kind of get stuck. So we have a couple PRs, right? So that's the API, and that's the controller. Controller is the one that manages those hooks. And then during this API, so you can see that during this. So that's, the team have some comments there. So we think,
Cool. So I guess, I don't know if others want to give their feedback, but it sounds like Big Storage has spent a lot of time exploring this problem in a depth that this is the first time I'm aware of it coming into SIG-Node, so it's probably going to take some time for us to think through.
Okay. Now, do you want to? I'm not sure what's the best way for you to evaluate this other approach, because now you are suggesting us to look at how to do this one outside, and then.
I wasn't trying to dissuade you from either outcome, I guess. I was just curious if you had explored this outside of.
Yeah, we have, right? So you see that we have this, then we basically get in comments from both Tim and Daniel's, and it's Daniel somewhere too. Yeah, Daniel, he was saying that. They were saying that because even in our original, in this cap itself, we also listed these other approaches as alternatives. So basically, we have a main approach, which is completely CRD, and then we have those alternative approaches, which is to doing this. Adding those comments inside the container. It's slightly different from what we were showing in the container notifier. Right? So, but this is still, we're trying to add this one inside the lifecycle. And similar, not completely the same. When we're implementing it, we got feedback from API reviewers saying that we should really seriously consider how to do this inside the container itself. What is your suggestion? So should we, I don't know, should we have another meeting and then maybe invite those API reviewers to be there too, and then we can discuss? I'm not sure then what is the way for us to move forward.
Yeah, so I think the questions I was asking was more trying to understand the impact it would have to the kubelet
Yeah,
And
definitely.
those
Yeah.
need to be a kubelet in order to support the API. So like, I think the next step would maybe be supplementing your write-up here with a little more depth on how and when the kubelet would be expected to batch these updates, how garbage collection would work, how I forget the other things I had raised, but hopefully we can go back and record and look at it.
Yeah, I took some
probably
notes.
like the right next step, but I don't want to make my first, reflections on the idea being presented here as like the final reflections, and I'd like to hear other voices in the city.
Mm-hmm. Okay, yeah, we can do that. Yeah, we can. Shanchen, do you have any thoughts on this?
No, I think what they're meant it's perfectly makes sense. So we need to be able to answer those questions anyways. So if there's anything from Signal that with regarding to this cap and this idea, please let us know so that we can do our research. And if you have more resources in the Signal, if you do have some examples that we can look into and some standard we should be following, etc., that'd be highly appreciated.
I guess the other general thought I have here is like, is there some convention you're expecting for container notifier terminology that says this is what, like in your Mongo example, unlocking tables or something, is there some spec or standard you guys are looking to apply that gives these arbitrarily named notifiers meaning?
We don't have to. I mean, if there is a better name, it does not mean that we have to.
No, I mean, like, it looks like the notifier name is user defined and so arbitrary. And so what I was wondering is like, if from the start.
Oh, you mean like the specific ones, like if we want to say Quias or something that.
Correct.
Yeah. So. So if we are doing Quias for snapshotting, and then usually we call it Quias or freeze, those type of, we use those names. Yeah, there are some common names we probably should use. But for other type of use cases, I'm not so sure. Right? So there are many other use cases that I don't know what are the better name for those. But for
stick storage though, if there were use cases, could we just list those?
So for example, Quias, that we can definitely, or we could freeze, maybe it's easier to write that down. So that those we do have some common names, right? But for other use cases, then we list a few use cases here. So first one, we can just say either Quias or freeze, something like that, right? So that type of thing. But for the others, I'm not quite sure what would be a better name. But for those, we can, because those are the things that we need.
So I guess the other part I wonder about is unquias and quias basically implies like a memory of the state of a particular container beyond delivery of the signal. Is there a place where you're trying to record that state? Because the notification signal is an imperative command to do something and figure out that the command was done, but it doesn't capture a record of something like Quias.
Yeah, so we are not saving anything. It's the application itself, right? So we just run like for example, log tables. Then the database is frozen, and then we can take a snapshot, and then we unlock tables, something like that.
So in one of your examples, you're saying you send a signal. So how do you know that your signal succeeded? Like if you started, you send a signal to start an upgrade, then are you going to check again? Like I think that's what.
Yeah, so I think that's the challenging part, right? So that really depends on what command you are sending there, and then what is the success. So I think those are definitely very tricky. I think the varies depending on what type of signal you're sending, right?
if I could, maybe the one use case that I had in mind that we could explore that's really maybe more basic is right now we don't have a way to tell a pod to restart and or a container to restart. And that has been a request by others in the community for probably the last 4 years or so. And feels like maybe ground zero use case that we can build from. And I'm wondering if that's something that you had explored or felt was in scope of this proposal.
We didn't specifically try this one because since we are in the data protection work group, so we really only tested this one. Yeah, go ahead.
Sure.
Yeah.
If you click on the issue, that what Derek was asking. Click on the issue. Right?
Okay, yeah, this is a team actually.
This has been asked for long.
Yeah.
Long time ago.
The way to signal pod. Yeah, this is like 2016, 4 years ago.
If I'm not wrong, the container, signal the container to restart. It's one of the example over here as well.
That's probably true. But this one has.
There's a whole bunch of discussions that probably don't want to say, put too much effort over here, but in short, to answer Derek's question, our focus in the beginning is to do an application level snapshot and being able to execute some arbitrary command against a certain container. The original approach is, as Xin was saying, using pure CRD, but that requires very highly privileged controller to be set up to do that. And then we get some feedback, and Xin went back come up with this third approach. We haven't put any effort into other use cases, to be very honest. Does that answer your question, Derek?
Yeah, I was just trying to, I didn't know that you linked this, but I was just trying to think of the most basic signal, and restart was one.
This is Seth. When I look at this, the kubelet managing execs, I guess when I saw this, my mind went to, this seems like a DOS vector for the kubelet and the runtime, in that you can create these notification API objects, which the kubelet is then supposed to call exec into every container in every pod to run this command. And we always have exec has always been a problem. So exec based liveness probes, readiness probes, and then pre-start and post-stop, I think is what they're called. Yes, all of those have always had issues. For example, timeouts are not honored on exec-based probes because the runtime is just hung. It's just called in. It's just exec into the container, and there's no way to get the call back. It just sits there forever. And so, exec is really not an awesome mechanism for these kinds of things. And given the lock tables example that you're talking about, I mean, it would be much easier to do that at a higher level and just make a network level call into the pod, and the pod has some API. The container has some API inside of it, right? That when you hit the / lock tables endpoint, there's something in it that executes lock tables, right? Or I mean, it could even be at the application protocol level. It just doesn't seem like the right level to do this at to me, and I do worry about the kubelet doing a bunch of execs because it's exec has always been a problem in the kubelet.
Okay, so your suggestion is actually better just to do this one for a high level, like what we had before, basically, our previous approach.
Right. For example, like an application operator.
Yeah. Right.
So you create a CRD that represents a Mongo database in this example, right? I mean, the way my mind would work, the solution that I go to is you've got a CRD that represents that Mongo deployment, right? And there's an operator that's managing that Mongo deployment. Well, you could just set something on the CRD spec, say quiesce equals true. The operator sees that, and the operator connects to each of the pods and does whatever it needs to be done to put the pods in that state, and then reports back through the CRD status that yes, the database is quiesced. You can snapshot it now. That would be where my mind goes.
Yeah, I think that's currently how those people. I mean, like people who want to back up and restore the database applications. That's the current approach. Yeah.
I guess I kind of echo Seth's sentiment there, and like, are we trying to, like what Seth described as present state of the art that people are being successful with? What I would wonder is where and how that's breaking down by getting this into the core. We make something better, and that hasn't yet been clarified to me, because when I asked like the signal names, it seems like those signals might vary by solution, and so it wasn't clear if there was a taxonomy for these signals that you guys were looking to build on top. But I don't want to prejudge any necessary.
Right. I mean, since like our focus is in the snapshotting, right? So for that we do have some common names, right? For other type of signals, and we really have not done that much research. So, like if you say restart or something, we can come up with those names if that's like the common signal that we want to support. We could do that. Just to, we can say, okay, here are the common signals that we want to support. We can start with those. We just support those, and then add some others in the future. If that's that makes sense.
Maybe Seth, you could record some of your lived experience with exec actions, because it's probably a different perspective than others might have. And I think otherwise, maybe as a next step here, we capture the challenges both with execs and breadth, as well as other alternatives, like an application level operator or something like that Seth explored, and maybe we can come back and revisit the topic once those updates have been made.
Yeah, sure. So Stas, you can help with the application operator side?
I mean, I can write my thoughts down. I just don't know exactly where. You said that there wasn't a cap open for the current.
Yeah, well, the cap was already merged. The one that uses the CRD approach. So how do I do that? I can add that at the end of this doc. I will just add that at the end of this doc. Or do you prefer to add your thoughts in this doc or in the signals doc, or whatever you prefer to do?
Yeah, whatever works best. I mean, I think what this solution is trying to get at is kind of a generic notification mechanism, right? Or what I was talking about is more application specific. And I do think that in reality, these types of operations are going to be application specific for the most part. That's all I've got.
Okay, so I added this link here. Should I add this in the signal doc, or what? What should I? Is it okay just to add this one? So if you want to take a look of what we had in our CRD approach.
Yeah, if you can provide links in the agenda to all materials.
Okay, sure. I'll do that. Okay.
The CRD approach, is this option 1B?
Not option 1B is actually inside the containers. The CRD approach is actually the main approach in that CAP, in the merged CAP.
So it's the proposed one.
Yeah.
Just the merged CAP included the change to the pod API definition itself.
No.
No, it has some examples like how you use it, but it does not change the pod API.
Okay. We spent a good bit of time on this, and I just want to be considerate of others who prepared an agenda.
Sure.
So maybe if we could move on to the next topic, and a big thank you for joining us today to share your ideas.
Thank you.
Hey, Derek. I'm Chris from Samsung. I'm for the third point in the agenda. Could you allow me to share the screen?
Yep, just give me one moment.
Okay, I'm aware that we don't have a lot of time. Actually, the presentation is a little bit long, and I will do the first part. It is a little more briefly, and then we will see what to do with the second part, if to reschedule it or maybe something else.
Sure. You should be able to present now.
Okay. Okay, I will go briefly through the most important key points, and if anything won't be understood or if you will need more explanation, just let me know and I will go back. I'm Krzysztof Jacek, and this is Chris from Samsung R&D, and we prepared a presentation to discuss about Topology Manager changes and NUMA-aware scheduling. The presentation was designed to have two parts. We will see if we will fit with this one. The first part is regarding the Topology Manager proposal that we presented two weeks ago, and the second part is about NUMA-aware scheduling and some approaches towards the issue that we came up with. Let's get started. The proposal that we presented, its motivation was to bind two pods with different topology requirements to the same worker node. And our approach to resolve this issue is to introduce the new field in the pod spec. And as the feedback and opinions came to us, we may started to think that this may not be the best approach, so we came up with the new idea to use the annotation field for this, and we think that this may be a way to go. And another way is the approach C, to use the new field topology policy in the runtime object. And this would look like this, the runtime class and topology policy. And this is the new ways that we can go with the pod spec extension. And also there's a new approach for the general topology manager policies. In our CAP and the proposal, we thought that maybe the deprecation of the topology policy flag on the kubelet is a good idea to not confuse the users how the topology policy is selected. But we can also go with another approach that there won't be any deprecation of the policies, so the policy can be specified on the pod level and on the node level. And the use case for such approach is when the user wants to have a workload server destined only for particular workload, for example, high-end performance server, and only for single NUMA node policy. So in this scenario, if user will specify a node level policy other than dynamic, it takes precedence here. And if he will specify the dynamic policy, the policy for the pod will be taken from the runtime object, or from the annotation, or from the pod spec field. Using the annotation has some pros and cons. The biggest pro is that we would avoid touching the pod spec, and this might be difficult to modify the pod spec. And also we can promote this annotation as this pod spec field or the runtime class object when the feedback from the users become decisive. And the disadvantage of this approach is that some users may be confused that they have to specify the topology policy of a pod using the metadata in the pod spec. This may confuse someone. And also we can go strictly and choose the approach C, and not go from the annotations to the runtime class and directly go to the runtime class. And this is also will be easier than extending the pod spec, but the disadvantage is that it may be hard to determine what policy should be used when other than dynamic policy is configured on a node. And also the runtime class is specified on topology policy per pod. There are several uses.
Chris?
Yeah. Yes?
Would it also be possible to put an annotation on the runtime class?
I'm not aware of something like this. I haven't considered that. What do you mean annotation on the runtime class?
Yeah, I tend to think of a runtime class as just a bag of keys with arbitrary values that ultimately get handed down to a CRI to say, do something. So to me, it's like the most open-ended schema in my mental mind.
So you're saying...
Well, not exactly. So CRI gets only the field which is part of handler.
Just at the most macro level, I'm saying I've always thought of runtime class as just an arbitrary map. And so I think I don't think Jay, your initial suggestion is not out of the realm of possibility.
Okay, let me go forward. We have several use cases for the topology policy here per pod and for our changes. Practical telco use cases, we can say this is the user stories, is that UPF from the 5G requires NUMA assignment, and it was mentioned earlier in the presentations. vRAN and ORAN, this is also from 5G, requires CPU memory device pinning for proper deployment. And also MEC, which is the mobile edge cloud, blueprints requires CPU memory pinning. And also the MEC deployment has 1 or 2 servers that have the architecture software, and also will contain the client's applications. And in this scenario, the topology policy per pod is required to in most efficient way to utilize the resources of those 2 servers or this 1 server, because different applications can have different requirements. Those below requirements stems from the 5G. I presented them in another presentations. Let me just skip them. The issue from the topology manager right now is that if you would like to grant the allocation of resources, of all resources for all containers in a pod from the same NUMA node, we can do this. We can't do this right now, and this can cause a decrease of performance. So there are several potential ways to resolve this issue, and the way that we proposed in the CAB, and we think that this is the most efficient one, is to employ the topology policy per pod, to bind multiple topology policies to the same worker node, and also to introduce pod-level single NUMA node policy, which will allow us to allocate all of resources for all of containers from the same NUMA node. If we wouldn't introduce the topology policy per pod, we would receive the second way here, and if we would deploy a node with that kind of policy, and the requirement for such pods will be not high, the total utilization of the server won't be big, or maybe even otherwise some pods can be rejected if they will be scheduled to this node. So not providing here topology policy per pod can cause some issues. There is also an alternative way to resolve this issue, but it is totally not preferred, and this is the worst scenario here, is to introduce the NUMA device plugin, which would register a virtual device that would represent each NUMA node to the device manager. Generally, it is not scalable and requires a lot of manual work. We learned some things from the topology policy that is specified per node. First one is that admit handler for topology manager is always called when the pod is bound to the node, and then topology manager always collects topology hints from all hint providers and then merges those hints, even if the pod doesn't request any topology hint supported resources. And also there's a scenario where admin wants to deploy a high-performance workload server, and for example, this policy for this server will be single NUMA node, but not all the pods that are on this dedicated worker nodes requires the benefit of this configured policy. Examples are Calico or Multus or another agent that collect logs or something like that. We find that there are some benefits for the topology policy that is specified per pod. The first one is that if we will introduce the topology hour scheduling plugin called topology plugin, this is the second part of the presentation. Basically, it will work for every created pod in the scheduler, and it might be the performance issue. With using the topology policy per pod, we can use this plugin only for pods that has strict topology requirements. The second benefit is that operator can apply particular topology policy only to the pods which really need coordination of resource allocation for performance in the worker node. This is the issue from the previous slide. This will reduce the total pod admission time of a node. The third benefit actually was featured by Mr. Sherik from the Ericsson. You can find it here. And it allows us to deploy DPDK pod with soft limitation and DPDK pod with strict limitation. So two different policies to the same worker node. And also there is a benefit for my team goal, which is to deploy a DPDK pod with single NUMA node and a DPDK pod with pod level single NUMA node to the same worker node. And in this case, we can have a common worker node for the DPDK workflow, and we don't have to separate nodes and the workflow for different nodes because they have different requirements. That will be all for the part one. What do you think about the approaches? What is the desired approach in your opinion, and maybe what are the next steps to go? That's are my questions, and let me know what do you think.
Yeah, so I think that's a lot for a number of us to absorb, so appreciate you going through that. I had reviewed, I think, an earlier form of this deck that I think maybe Victor, you had shared. And I think at the end of the day, what I'm struggling to understand is like, or not understand, I'm just want to be clear. It feels that within the Taco space, there's a strong feeling that the control plane needs to be node local topology aware. And I don't know if your policies on the pod spec kind of talk to it. And I don't know if what I was looking at was part 2, but in earlier iterations of the deck, I thought I saw that there was some discussion on having the scheduler phone out to each kubelet to know if a scheduling decision was going to be accepted. And what I'm wondering is, I think the motivations for why this desired is clear. Maybe what I'm trying to work out is where and how to best represent topology information so that the control plane and data plane of Cube aren't confused.
So you're concerned if the pod spec on the runtime class is the best way here? I'm not sure if I understand that.
I'm struggling, Victor. Maybe you confused me this morning when I finally read your Slack. I thought a group of y'all had got together to talk through options, and I reviewed option B, which was basically pod spec to be topology aware, but then having the scheduler be topology aware. And
let me just add in. So Derek, you're right. We did. Some of us met a subgroup last week, and during that meeting, what we were mainly focusing on was how to make the scheduler NUMA aware. And I think that's part 2 of Chris's. And so I myself didn't particularly review part 1 of this either. And I thought today what we were going to talk about, and this is probably my oversight, was how the best way to add NUMA awareness to the scheduler. And we had looked at a couple of options, and one was sort of, I thought that we had sort of coalesced on was having sort of a call out from a scheduler plugin to the kubelet. And, there was even some feedback, I think, from BG and Chris and Alexi from the 6 scheduler that says, hey, there's no way we're going to be able to call out from scheduling context to the kubelet. And I think that was sort of on a bit on Slack. Yes, that's the day before. But the thing is, I had pointed Derek to that, and so Derek, I think, spent cycles looking at that and provided just a little feedback this morning. And so I think, this part 1, Chris, is I didn't quite prepare for this meeting to look at this and provide feedback either. For this particular part, I was thinking we were going to talk about the scheduler and how to potentially add the NUMA awareness there. So I think there was probably a little mix up in the signals.
Yeah, I think in general, though, it's hard to provide consensus on the first part, which is basically allow you to make this choice on a per pod basis, which I understand why you want to happen, without understanding how that is ultimately done. So I think let's take it as understood that there's a strong desire to inform at the pod level how to make a node local scheduling decision so that we can extend and enhance what's there in the kubelet today. I think the key thing to understand is assuming that is an agreed upon principle, how is that information made available on the control plane via a place to rally on in the API server without needing to do point-to-point communication between the various Cube components.
Okay.
May I ask you a question? In case of carve-out approach, can we do this call through IP server? I mean, call from Cube scheduler to kubelet through IP server. Is such proxy allows?
I think in general that approach is contradictory to the general Cube architectural goals, which was we should have a set of components that rally around config and state and reconciliation by just reading state from API server and not having to have components communicate directly. So like the idea of a scheduler talking to each kubelet is, in my view, like an undesired outcome. And like the communication between that schedule and the kubelet is difficult to probably secure and manage. And it also makes the scheduling component, which is typically run where your control plane is, having to start to reach out to other decision points that kind of go into the cluster data plane to figure out what it should do. Versus, like, I think in the feedback I tried to put on the deck beforehand, or at least one of the decks I had seen, was saying, okay, I appreciate that there's a desire to make the kubelets node local topology choices influenced externally. And so the kind of thought I was wondering if you guys had explored was saying, let's imagine there's a new topology management component run on the control plane. It could be a pod co-located with the scheduler. I don't know.
Okay.
The kubelet consults that component, like a remote topology manager, to figure out how to do something rather than making that choice locally. But in that regard, you have the kubelet phoning home to a control plane to figure out what to be done, rather than the control plane phoning out to each kubelet to figure out what should be done. And I don't know if that was explored in great depth, but in general, I would not recommend pursuing solutions that have schedulers making RPC calls out to each kubelet.
Okay, this is understood, and it would be great to also discuss this if we would go through the second part, because the approach A and A1 are connected with making decision in the control plane, and it's hard to talk about this going much into detail. But the problem in this approach A and A1 is that there are two different decisions made, one by the scheduler and one by the admission handler, and that there was this problem that could be solved by taking topology manager in the another plane. But
yes, Chris, that's exactly what we discussed. Is like why the data is down there, and the thinking was why would we want to sort of almost replicate the data up into the where the API server could get it, so we can make that decision at scheduling time. And I think the overall feeling was we were thinking, hey, why can't we just call out? I mean, the data's there. Let them make the decision one time. But if that sort of breaks the architecture, which I didn't know, I don't think any of us were thinking, hey, that was an architecture no. Then the other options that we talked about, which was essentially exporting the data from the kubelet, so that, for example, the scheduler plugin could make that decision instead of making a call out. That option was there, and there were a couple options discussed, which are probably still viable now that the direction is saying, hey, don't make a call out from scheduling context to the kubelet. So it sort of tells me, well, let's get rid of that option and go back to look at I think options A and A1, which really come down to what is the best way to export the data. Either and your options were, I think, extending the node object or come up with another custom object, and then what decision do we need to make? Is it the same decision that the topology manager makes now at admission time, or is it just really a subset of that, and try to do a better job of narrowing down which node can meet the resource request from the pod spec, so that the scheduling decision does have at least a much better view and has a much better chance of landing on a node that can meet those requirements. So I think what I got out of it is we need to go back and say, hey, don't make the call out, and let's talk more about option 2, figure out what's the best way to get the information there, and then go back and look at this sort of part 1 about, okay, how do we represent that? Do we do an API change in the pod spec to do it per policy per pod? Because I think there's some good stuff in there that you guys have worked on, and I know for me myself, I would certainly like to spend a few more cycles, and I'm pretty sure that both Kevin and Connor and Francisco, all of us that were there, looking at this would appreciate a few more cycles to look at that. And it's yeah, I think that's sort of the next step.
I wanted to strongly present the second part and discuss it today, but my question is what we should do right now if I see that we have a lack of time, so I don't know, go to the second approach and just present it quickly, or maybe reschedule it to other sub meeting, or what do you think would be the best way here to move forward with this?
Yeah, I'm willing to keep the meeting open just so that you can capture your thoughts, and then we can upload it to YouTube for those who can't stay to review. And so if you wanted to spend another 10 minutes to walk through your proposal, that's fine. And just understand that those who can't stay will have to catch up and provide their questions afterwards.
Okay, I think that 10 minutes will be enough. Okay. So all of the approaches, the first one approach, the second one approach, are based on the scheduler framework. And for those who don't know, scheduler framework is a pluggable architecture which makes customizations of scheduler very easy, and it adds multiple extension points where plugins can be invoked. And as you can see on the picture, we have scheduling cycle and binding cycle, and we have different extension point here, and in those extension points, plugin can be called out. This is how the broader scope of the scheduling works right now, and here is the scheduling process. And in this process, the plugins are called. One of such plugins is the node resource plugin that is called in the filter and the score phase. And it uses the alco table field of the v1 node object and the request field of the v1 pod object, but it is totally not NUMA aware right now. The issue with non-NUMA aware scheduler is that right now operator needs to provide some node selector to specify the particular node that can handle the topology requirement of the pod. If you want to specify that, and will create the pod, and scheduler will try to schedule this pod, it can be bound to the node that can satisfy the topology requirement, and there will be a pod rejection with the topology error. And operator can manually try to reschedule the pod, and there can be another rejection until the node has enough of resources. This issue exists regardless the proposal of the topology manager. This is important to mention. Also, we wanted to mention here that we were strongly focused on the node level changes for right now. I'm in the Samsung team, and this is the topology manager, CPU manager, and the memory manager as new component. And we wanted to move forward to the scheduler enhancement after the first part is done. But we thought if there's the issue right now, maybe we can move in parallel with the second part with community. And this is the A approach that we decided could be a way to go. And this is enhancing the v1 node object and providing a scheduler plugin. The v1 node object has additional field to store information about availability of NUMA resources. This additional field of fields can be a sub-part of the allocation allocatable field or the capacity field. So maybe this may not increase or provide new fields in the node object. And the scheduler plugin will be used to select or score the nodes that could satisfy the requirement. Challenges with that approach are: the first part is that right now Kubelet doesn't maintain node resources at the NUMA level. It don't have information about that. So the challenge is how to collect them and expose them to the v1 node object. The second challenge is how the plugin should score the nodes. The first way is that it can filter the nodes that can't handle the requirement, and the second, and it can be done like first feed that pod can feed there, and it is selected right away. And the second way is that plugin can score the nodes. And also, here is a change how to do that. There's a concept of scoring, and this is made by Alexey Peravelov, and you can find it right here. It can be also applicable for the other approaches, I think. And there is also a challenge that scheduler plugin, which scores the nodes, doesn't guarantee the pod is that will be deployed on the node, because there still can be a rejection on the bound node. And this is the issue I mentioned, that scheduler can make his decision that, okay, no, the pod can fit to this node. It binds the pod to the node, and the node calculates the hints on its own, and then it produces the admit message on its own, so it can still reject the node, because there is like, let's call it split brain here, two different decisions. This is how approach A looks like in the broader spec. The red parts are the parts that are changed by this approach, and the important disadvantage, or the maybe challenge, is how scheduler can calculate if a pod's requirement can be satisfied on the node. Because if we would run the same hint calculation algorithm, it may cause a huge decrease of scheduling performance. Scheduler approach A1 is nearly the same as scheduler approach A, but instead of providing new fields into the V1 node object, we can use a new built-in object, or maybe a CRD object to store the NUMA resources information, and the rest is exactly the same. Scheduler approach B, I don't know if I should go through this, if we think it is a rejected approach. What do you think?
Yeah, so I would think scheduler approach B is not worth reviewing, given that the communication between scheduler and OMN nodes is not a recommended approach.
Okay. There's not a lot of slides to the end. This is the comparison of approaches, and okay, so B is not worth mentioning. The advantage of this A approach is that it respects the architecture of Kubernetes, and actually there is a SIG scheduler maintainer that left a comment, and probably he is behind this approach. Maybe we could get more opinion about that, but I think in the comment he implied that promoting a CRD or built-in object with out-of-tree plugin to the in-tree plugin would be a good plan.
Chris?
Yes?
Hi. What would store the mapping, the association between a pod and the NUMA cells and cell resources, cores, memory banks, huge pages, whatever, and the pod, like the allocation of a particular NUMA cell specific set of resources to a pod, where is that being stored?
I think if we want make here a new approach with moving the topology manager to the control plane or something like that, this can be still done the same way. So this is handled by CPU manager, the pinned CPUs, and the memory manager for the memory cells. And the information that will be exposed, it is the amount of used NUMA resources, and the amount of that is free.
Right, but the way that you're proposing that a pod would request a specific topology is via a string indicator, right? Like, single NUMA node or whatever. It's not necessarily it doesn't necessarily say what the pod has been assigned.
Yeah, I think that's something that would need to be fleshed out. Like obviously the pod spec says which node name a pod has been bound to. There would need to be
which NUMA cell a pod or its containers have been pinned to, right?
Yeah. And so I think that information is lost in A or A1, and I think Jay is right to call that out, because there's no sense in making the information available in A or A1 if the actual pinning decision isn't being made on the control plane itself for the kubelet to respect. And so we need to show how that would be. And if that meant that you'd have a future topology manager plugin option that said remote, and it knew how to fetch that resource to find that pinning decision, that maybe is what you could do next to supplement either A or A1.
Okay, sure. Thanks for that. And just quickly to the end, and the advantages are that there was some concern that NUMA-related information shouldn't be exposed from the kubelet, and in this approach exposes this information. The second concern is this split brain scenario that there is the calculation on the scheduler side, and there's this calculation on the node side, and it may be the same, but we don't have any idea for this solution any solution for this right now. And the third disadvantage is that the pod still can be rejected on the node.
I think though that the option, the column number 3, the likelihood of that happening is significantly reduced, right?
Yes, correct.
Yes, of course.
Yeah.
But it was presented here.
Yeah, and even if that does happen, I mean, it should be rescheduled, and it's we would get another chance, and the chances that we would have a much higher probability, I think, of choosing a different node to schedule the pod to the next time.
Yes, this is exactly the case, but it was mostly here put as a disadvantage in comparison to the B approach, which basically eliminated this kind of the problem.
Yeah.
That's why it's here. But as you can see, it is the very rare problem.
Yeah, I guess just to be clear, you're assuming that problem would exist in B if you had dual schedulers, and so I'm not clear how exotic all the potential environments are that are being represented by telco use cases, if it's always a single scheduler environment or if there's multiple schedulers. But yeah, I guess in general, to me, that the thing that's needs to be understood is either A or A1. You're basically saying I want the control plane to decide both node and node local awareness scheduling decisions, and so the next step needs to be like, if that is to be agreed upon, then where do we capture the node local scheduling decision that the kubelet acknowledges?
And when we end up with a problem, what control plane actually need to understand what NUMA node is actually meaning. Because if you have a heterogeneous cluster where you mix like Intel and AMD machines, or well, Intel and ARM, the node meaning is different. And when you have like CPU-less NUMA nodes and so on. So if interested, I can just pass in the chat the example of where it all will fail.
Yeah, I think that's always true, and that's why every time we discuss telco use cases, I'm always curious to know which choice are we willing to make to constrain the problem space, and obviously that is one such potential choice. that could be made to constrain, as well as just going all the way back to months ago saying, this node can support X number of counted pods. And so then you didn't run into this arbitrary scheduling problem because you had a uniform homogeneous pod unit you were scheduling with fixed sizes. And I've yet to hear, and I don't think I'll ever hear, like a way to constrain the design space so that we don't have to support everything. But I keep hoping one day I'll hear that. And so I think in general, though, if we can go next step on ARA1 to understand how the control plane would want to make a node local binding decision observable to the kubelet, that's probably the best way of enriching either option.
Do we know if it's possible?
So let me, can I ask one question? So you mentioned that the calculation is sort of expensive. So does that one-time calculation? So for example, one subpod is assigned sort of NUMA index on a specific node. So the calculation happens on that node specifically, and that calculation is one time, right?
I'm not sure if I understood, because we are considering approach A and A1, and in this case.
I know. So I mean, the metric or the kind of spec has to be reported by the clean calculation algorithm from either the kubelet or some daemon set pod, right? So my point is that I want to understand whether the calculation is just one time based on the pods assigned to some specific NUMA index or resources on that node. So I want to understand how dynamic the calculation will happen. So yeah, it will impact how frequently it reports the metric or the spec back to the API server as a CRD or as a standard API object.
I think that would happen on every pod assignment that was, assigned to a node that was requesting NUMA alignment, right? It would have to, else the next pod scheduled would be, inaccurate.
So, is that possible to move the calculation to the control plane? So, maybe I'm wrong. I just want to understand. So suppose we are at the very first moment. So no pods has been assigned. So right now the spec of the NUMA on each node is static, right? So we have that static information, just like what we get from the kubelet available resources. So that's available on the schedule side. And then based on each pod scheduled and assigned to a node. So basically, scheduler knows where it goes and what kind of resources it requested, so that it can deduce from the initial moment of the NUMA resources, then make the scheduling decision upon each pod. So I'm not sure if I understand it right.
Yeah, so as you said, when the scheduler takes that pod from the queue, it has to somehow decide if the node that is taken, for example, there's an amount of nodes taken into account in the scheduling cycle for that pod. This number can be, I think the default was the 100, and so if he has to decide if this pod's requirements can be satisfied on a set of nodes, and if these nodes can fit this pod. So it has to run something like similar to the calculation algorithm. And in this way, how this should look like, it is one by one in the best fit, or it should run for all of the nodes. And this is the problem here that will decrease the performance. I'm not sure if this is the things you ask, but this is the problem.
I'm just trying to understand why it's mandatory to run the calculation algorithm just on the node instead on the control plane. Because it seems to me it's like that the control plane can get initial information of all the numeric resources, and based on that, upon each incoming pod, it can calculate to do addition, deduction, sort of, and based on the calculated numeric resources to do the iterated calculations. So
one part is the scheduling part to say, hey, will this pod with the requested resources fit on that node? And when the answer is yes, then the next part is to say, okay, the pod is scheduled on that node. Now we need to talk to each one of the device plugins. For example, CPU manager, device manager that may be doing SRV or GPU said, okay, now the pod is here. Allocate and go allocate these resources and assign them to this pod. For example, if they want 5 exclusive CPUs, here's the CPUs that this pod and the containers in the pod are, assigned.
So
and that wouldn't happen up in the control plane. It would be just more of looking at will it fit or not, and not doing the actual. At least that's my understanding. Not doing the actual allocation and reservation. Now, that may be fine tuned to try to minimize race conditions, but I think that was what we were sort of looking at and talking about in the initial discussion.
Okay, that sounds to me that calculation is not that static and cannot, at least some of the information cannot fully report it to a control plane so that control plane can do a real simulated calculation. Right.
Hi, can I say something? Hello?
Yes, we can hear you. Go ahead.
In the kubelet, there is a topology manager and CPU manager and device manager. And CPU manager and device manager provides topology hint to topology manager, and topology manager just merging that hint and figure out what is the best permutation for a container. So the problem is if we try to move topology, full topology manager to the control plane, there should be a way to expose the topology hint from CPU manager and device manager to control plane also. I'm not sure it can be answer for you, but I just wanted to share it.
Yeah, I guess when I think about it, I think that the information that is exposed about the resources and the NUMA is really just a subset of what is in Topology Manager now, and that we do enough calculation to see that the resources are available on a node that can meet the alignment as specified in the pod spec, and the actual allocation, reservation allocation still occurs in the kubelet at the node level inside of Topology Manager, just like BG explained.
Yeah, I think Victor, that makes sense. Like, I don't think you need to move all hint generation for device plugins to the control plane as an example. Like, I wouldn't expect the control plane to become node local NV link aware or any other random interconnect that might happen among devices. And maybe that's a limitation, but I do think we could find a way to export a minimal set of information to mitigate the risk of a scheduling decision ultimately being rejected. I don't know if we'll ever get to 100% of that, but I think we can probably explore ways to export a subset of it that you can reduce the incidence of that risk that would be acceptable.
Yes.
I'm still not sure that the present behavior is actually unacceptable either. And so quantifying that is probably helpful.
Okay, if that's all for this, I have last slide for this presentation, and it is connection between the scheduling and topology manager changes from the part 1. Because the problem is here that if we have a dynamic policy specified on a set of nodes and a single NUMA node policy specified and set of node and etc., how we can decide where we want to deploy the pods accordingly, when the pod spec has to be used and where not. And the first way is to add the topology policy as a built-in label, and then we can use the node selector in the pod spec. And I think there should be OR and or runtime class scheduling. I'm not fully aware how this works right now because this is the fresh idea here. But in this way, we can choose basically which set of nodes with what node level policy we want to deploy the pod in. And the second approach is that we have this topology policy labeled as a built-in label, and the scheduler plugin can use this to directly select the proper node. But there is an issue here that if we have the dynamic policy specified, and for example, there's a single NUMA node policy specified in the pod level, and there are also nodes with single NUMA node policy, how this should mix and how the nodes should be chosen in this kind of this scenario. But this is a concern for this kind of way, and this is, I think, the issue that is with interconnecting those two things, and regardless the moving topology manager for the control plane is obligated, because we weren't thinking about that in this moment. And this is all for the part 2. Thank you.
Okay. For those that were able to stick around for the extended materials, thank you. I will conclude the meeting. For those that are exploring the space, appreciate all the deep analysis. And it sounds like there's a set of next steps for folks to iterate and think through. I know we didn't get a chance to get an update on the testing infrastructure. I'd like to queue that up as the first topic for next week's meeting. And thank you to those who had already met and started iterating on that. So, bye, and have a good day.
Bye. Thank you. Bye.
Bye.